Paper I. The topic of delocalized covalent bonding sits within the atomic structure and chemical bonding section. Questions here are highly technical, demanding precise mechanisms, molecular orbital, MO, depictions, or thermodynamic arguments. Here is a selection of high-yield, exam standard questions with model answers. Question 1, 10 marks. Account for the fact that the two CO bond lengths in the acetate ion, CH_3COO, are identical, 1.26, text R, whereas in acetic acid, CH_3COOH, they are different, 1.21, text R, and 1.34, text R. B. Draw the qualitative molecular orbital, MO, energy level diagram for the pi system of the allyl radical, CH_2 equals carbon monohydride CH_2, bullet. Indicate the frontier orbitals and the position of the unpaired electron. Model answer. Bond length divergence. In acetic acid, CH_3COOH, the pi electrons are localized primarily between the carbonyl carbon and the oxo-oxygen. There is a classical carbonyl double bond, C=O, which is shorter, 1.21, text R. Due to higher electron density and greater S character, and a single bond, CO, which is longer, 1.34, text R. However, upon deprotonation to form the acetate ion, CH_3COO, the negative charge on the oxygen atom undergoes delocalization via resonance. Because the two canonical contributing structures are completely equivalent in energy, the actual structure is a true resonance hybrid. The pi electron cloud is symmetrically delocalized across the OCO framework, intermediate length of 1.26, text R. B. Allyl radical, pi-MO diagram. The allyl radical is a conjugated system containing 3 p orbitals perpendicular to the molecular plane, contributing a total of 3 pi electrons. Linear combination of atomic orbitals, LCAO, generates 3 molecular orbitals, Psi_1, bonding, Psi_2, non-bonding, and Psi_3, anti-bonding. Psi_1, lowest energy, 0 knots, wave function signs are plus, plus, plus. It contains 2 electrons. Psi_2, HOMO/SOMO, 1 node at the central carbon, wave function signs are plus, 0. It contains 1 unpaired electron. Psi_3, LUMO, 2 nodes, wave function signs are plus, plus. It contains 0 electrons. Note, in the exam, explicitly sketch the p orbital lobe signs, plus or minus, for each level to secure full marks. Question 2, 15 marks. A. What is Huckel's rule of aromaticity? Based on this, explain why cyclooctatetraene, COT, is non-aromatic while the cyclooctatetraenyl dication, COT-2, is aromatic. B. Discuss the criteria of aromaticity based on magnetic susceptibility exaltation and chemical shift, text, 1, text, HNMR. Model answer. Huckel's rule application. Huckel's rule states that a planar, monocyclic, fully conjugated system will exhibit exceptional thermodynamic stability, aromaticity, if it contains 4n+2 pi electrons, where n equals 0, 1, 2, 3. If it contains 4n pi electrons and is forced into planarity, it becomes destabilized, anti-aromatic. Cyclooctatetraene, C_8H_8, it possesses 8 pi electrons, 4n where n equals 2. To avoid the severe electronic destabilization associated with anti-aromaticity, COT adopts a non-planar, tub-shaped conformation. Because it is non-planar, pi delocalization is disrupted, and it behaves as a typical localized Pauline, non-aromatic, undergoing rapid addition reactions. Cyclooctatetraenyl dianion, C_8H_8, when COT is reduced with potassium metal, it gains 2 electrons, resulting in a total of 10 pi electrons. This satisfies Huckel's 4n+2 rule where n equals 2. To maximize the resonance stabilization energy of this aromatic system, the carbon framework flattens into a perfectly planar, regular octagonal geometry with equalized CC bond lengths. B. Magnetic criteria of aromaticity. When an aromatic molecule is placed in an external perpendicular magnetic field, B_0, the delocalized pi electrons circulate freely around the ring. This macrocyclic electronic motion creates a diatropic ring current. Chemical shift, text, 1, text, HNMR, the induced secondary magnetic field opposes the external field B_0 inside the ring cavity, but reinforces it outside the ring perimeter where the peripheral protons reside. As a result, peripheral aromatic protons experience a net higher magnetic field. They are highly deshielded and resonate downfield, typically, delta, text, 7.0 to 8.5.
+9 11408